Today I had a Sanyo DCX4000 come in for service from one of my viewers, and he's already replaced the main filter capacitors on it. But he's telling me now it's got a problem. It's humming. So I said, you know why it's humming? He said, why? I said, because it doesn't know the words. But seriously, it's got a hum in one channel, well, one channel's dead and it's humming. So this is going to be an interesting one to see what the problem is. So let's get started. So we have one channel working now and it's humming. Humming out of the left channel. It's humming out of both channels. The left channel is dead completely. And the hum it varies. Seems to vary with the volume, but maybe not. So the first thing we'll check on this, so we'll check the voltages on the main filters. We have a negative and a positive supply. So ground my meter to the ground point. I got the speakers turned off now. Minus 29 volts on the negative supply. Positive supply, plus 28 volts. That looks okay, but watch what happens when I turn on the speakers. The positive supply drops down to 20 volts. Negative supply is still about 27. So we've got a DC voltage going to the speaker. Something is loading it down. More than likely an output transistor that's gone bad. Now on this unit we have speaker protection fuses. There should be no voltage on either of these fuses at all, because this is going to be the speaker waveform, an AC waveform going to the speakers. So when we measure these, we should see 0 volts, which we do. We see 0 volts on the right speaker, but watch what happens when they go to the left. Oh, that's a problem. 24 volts. So if I turn on the speakers, I'm actually sending about 13 volts through the voice coil, which is not going to do it very good. We have a failure on the left channel. So if I just take out the speaker protection fuse, that will disconnect the left channel from operation, and the right channel should probably work without hum, which it does. So we have a problem on the left channel board. If I trace these wires, we'll see that the left channel board is this one right here. So somewhere on this board we have a component that's failed. A transistor, more than likely, has gone bad. So let's check this board. Now we want to make sure that there's no DC voltage going into the board, because obviously if you had a DC voltage coming into the input, it would be amplified by the amplifier itself. So to do that, I can check the input with my scope, verify that there's a signal going in there with no DC. So here's the input for the left channel. And oh, no music playing at the moment. Gotta wait for the music. So there's the left channel, right channel, nothing. If I look at the output that would go to the speaker, I'm on a times 10 probe, so this says 1 volt per division, but it's actually 10 volts because my probe is on the times 10 scale. If I clip it to the right channel, which is working, I see that there's nothing. If I clip it to the left channel, look at that. You know, about 24 volts. Is there any sound on there? No, there's no sound. Just DC. Just DC voltage. Here's something I just learned on the scope. I've had the scope for a few months, but I haven't really been paying much attention. It says 2.4 volts, right, because it's times 10. When I turn it off, as the voltage drops, you'll see the voltage drop. That's something I hadn't really paid much attention to the screen. I knew that my setting was here and my time was here, but I hadn't paid attention. It actually has on-screen voltage as well, which is kind of cool. Like I say, I'm learning more about this scope all the time. There's so many features of this scope which I really still don't know how to work because I don't have a manual for it. Cool. And of course that display only shows up if you're in DC range. Right. If you're in AC range, then that doesn't show. Same for the other channel. If I was using 2 channels, again, if it's coupled AC, you don't get the voltage reading, but you do if you're in DC, which is kind of handy. What some of these other readings are, this is my time base, 5 milliseconds, 2 milliseconds, and as I adjust the variable control, I can take it to 6 milliseconds or 2. So I have variable, right? A lot of features on this scope. A lot of features that still I haven't used. I haven't just scratched the surface. It's a hell of a good scope. As you can see, I found a place to mount my clock TV. Mount it up on the shelf there, get it off the bench. Free up a bit of space here. Okay, let's start troubleshooting this board and see what the problem with it is. Turn my torque up a bit. There we go, next one up. Okay, let's check the output transistors for shorts. I'm just going to check these in circuit for now, looking for any shorts, emitter to collector and so forth. So, okay, we may have a bit of leakage there. Let's check this other one here. I'll probably have to disconnect the leads. I don't have any shorts though. 0.2, that could be just a resistor internal. Yeah, they look about the same. I'm just going to disconnect the emitters and the bases, and we'll check the transistors without the wires connected to it. So do them one at a time here. Take off the pink and white wires. That way we can test the output transistors and see whether they are causing this DC voltage. Because a shorted output transistor certainly could cause this type of a problem, but it also could be one of the driver transistors, or it could be an open resistor in the bias circuit. So there's no short there, and we should get conductivity 1 for one junction. So there's collector to base, which is good, and here's emitter to base, which is good. So that transistor is okay. Let's check the other one. Again, we'll check the transistors here. NPN, good. And the junction here is good. And there's no reversal, so this output transistor is also good because we only have flow in one direction, so both diode junctions, because that's what a bipolar transistor, or BJT, bipolar junction transistor is essentially, it's like 2 diodes. So you can measure the diode between the base and the emitter, and the diode between the base and the collector, and you'll only get current flow in one direction, as we're getting here, right? There's our one diode, current flow in one direction but not in the other, and here's our other diode, nothing that way, and we get current flow in that direction. So both of the output transistors are good on this unit. So we'll look back at the amplifier. Probably a resistor that's gone open is what I'm thinking is causing this problem. As warm as it is today, I got to close down the door because the neighbors having a family get together, I guess, and there's a bunch of kids playing basketball and screaming and skipping in the street. You can probably still hear the noise. I can't hear myself think around here. It's like Grand Central Station. Okay, now we know that the output transistors are fine. It's going to be a bias problem, and this is the negative transistor, this is the positive transistor, and we had a positive voltage, which means that this transistor is the one was driven into saturation. Because if it had been this transistor here, then we would have had a negative bias. So our positive transistor is right into this circuitry here. Here's the base. This will be the driver transistor, and looks like collector. What is that? Is that base? This is the driver transistor here. Oh. Just the way it's kind of twisted here makes me kind of... Oh, I think I see the problem. I think I see the problem. Tin whiskers, as we like to call it. Take a look at the leads. Oh, this camera's not going to focus. I got to get the camera in closer. I see some tin whiskers on this transistor. Let me get the camera down a little closer here. This would explain everything on this this driver transistor here. Tin whiskers are a problem that plagued a lot of older electronics. I love this camera. I can just move it anywhere I want. When I get in close, I can get better focus. You guys see what I'm looking at here? Tin whiskers. Shorting my transistor. Yeah, lovely stuff. Let's just check the others for it. Because if one's got tin whiskers, then the others probably are also going to exhibit this phenomenon. Let's take a look at the next one over here beside it for the other side. And yeah, it's got some down here too. Let's just get in here. I don't know if you guys can see it or not because I'm looking from a different angle, but the other driver transistor here also looks like it could have some tin whiskers growing on it. We'll have to check the other channel because if one's got it, then probably both of them also will have it. We'll just clear this crap out of here. Yeah, this other one here definitely. There's some crud in between the pins on this one too. Bend that one over so you guys can see it a bit better. But see what I'm getting at? This crap that's in between the pins here. It's like metal, right? We call them tin whiskers. What it is it's just it oxidates the leads themselves. They oxidize, and I don't know whether it's just dust or debris or whatever is around in the atmosphere, but the leads basically grow a conductive growth, and it causes short circuits. I think we'll try this thing and see if we have any voltage on the output. You think that that's all that might be? Could very well be that that's the fault with this unit, and I've just fixed it. Let's check it out. Okay, here we go. I'm on the output from this amplifier module. No voltage. Cool, let's put the fuse back in. I bet it's going to work. I bet you we're going to have both channels. Right channel. I would say that's a success. Problem solved. Tin whiskers. I'll make the owner of this very happy. He's telling me, he says, I'll send you a PDF of the schematic for it. He replaced the main filter caps. In fact, he gave me the old ones he got back. He says, I replaced my filters and it's humming. He says, now I lost one channel. Yeah, well, the filters didn't fix it because I doubt that there's nothing wrong with the original filters. They're fine. What happened on this unit was we had a little bit of oxidation that caused tin whiskers to grow. I'm going to make sure that this channel is also clear of them before I put it together. And it caused an overbias, and then you had DC voltage on the speaker. So hopefully the speakers aren't damaged, but let's put this one back together and we'll test it. So put the circuit board back together here. Put the driver board back. There's a little heat sink that goes on here I've got to put on as well. But let me just get the screws in here first. I tell you, this cordless screwdriver has been quite useful since I got it. The only downside is none of the bits are magnetic. It's the only thing I don't like is that the bits aren't magnetic. I have to magnetize all the bits. But other than that, it's a great cordless screwdriver that, let's say I got it for nothing. I got it to evaluate, so evaluating I am. So my long-term evaluation. So we'll put the heatsink back on this transistor, which is just a clip that holds it up against this. It's actually not a heatsink. This is what's called thermal compensation. So what this does is, this transistor is basically being used as a temperature detector. This tab here is physically attached to the heatsink. So as the output transistors heat up with use, this heatsink will get hot. And as the heatsink gets hot, the heat will travel along this aluminum tab and into this transistor that is strapped to it. As the transistor warms up, the current gain will start to, or leakage will start to occur between the junctions. So typically sometimes they do it with a diode, but usually they use a transistor because a transistor is more predictable. You set up a specific current flow between the emitter and collector by just biasing the transistor on slightly. And then as the temperature changes, the current flow will go up. As it gets warmer, the current flow will go up, which will in turn be used to adjust the bias for the output transistors, and can be used as an over temperature sensor. Anyway, that's what that does. Board's back together. I just have to remount it, and I'm going to check this other one for tin whiskers before I fasten this one down. To service these boards, it's easier if you disconnect the ground wire. That way you can put the board through like that. But say before I mount it, I'm going to check the other one because it's a lot easier to work on when it's apart like this. When the two boards are together, it's a lot harder to see in here. So let's check this other board at the front here for tin whiskers. I bet you there are some on the drivers here. Let me get my extra pair of eyes on here, my good old hood, and check this out. Just as I thought, there are tin whiskers starting to form. So we'll just clear them out of here before they do any damage. All I gotta do is just run my pick through there and just knock the thing out. Okay, that's those ones in place. Reconnect the ground wire here so I can test it. I don't need that anymore. Okay, the dial is off a bit. We'll just adjust it pointer here. This should be 87.5, and it's measuring like 88.1, and this is actually 87.5. So let's just adjust the pointer down. It should be right on the 0 mark here. And it's actually adjusted with, this is the oscillator trimmer on the tuner here. So if we adjust this slightly, we can bring it down to where we want it, 87.5. There we go. Just looking at where the stations are here, that's not quite right. It should be about right there. 1-1. I don't have an antenna on this thing, so I'm not getting all the stations. I was trying to get them 99.3, that's about right. Yeah, 97.7 French, 96.9. Dirty. We'll clean the audio muting switch before I put it together. Well, here's the phono input. It's working.
So I bet you they won't.
Can't play that for. I can't play this song on YouTube. So, tuner or phono input is working as well. All I got to do now is check the microphone input and see how it works. So now we'll just try the microphone input before I put this together. So I got the microphone input on here now, and yes, you know it. I got a cheap microphone, but hey, you know what? It works, and. No noise here. A little bit of feedback. Tinny sounding mic, as it's I think this is about a 1965 Transonic. Actually, it's a realistic 500 ohm dynamic microphone made in China. What do you expect? But hey, the microphone works. I would say that this unit is a success, and we're going to put this one back together and send it on its way. There it is, back together, ready to go back to its owner. Sounding very good. The old Sanyo DCX4000. Got a humming and DC voltage on the speakers. Check for little tin whiskers like we had on this one. To say if both channels were affected, it was only causing a problem on the left channel, but the right channel probably would have done the same thing because the same transistors were equally affected. It just hadn't got to the point where it's shorted yet. So keep that in mind if you got one of these units. That happens on these. Okay, that's it for this one. Thanks for watching. If you enjoy my channel, do consider supporting my channel through either PayPal or through Patreon. I'd say all funds received through donations go into making more content. Supports the channel, keeps it on the air. Thanks for watching, and we'll catch you again real soon. Bye for now.